Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of our Blind 75 series, problem 230, House Robber 2. So I hope you have seen the video of problem House Robber, the problem that I have covered just before this. This problem just has a simple deviation from House Robber. In this problem, we have been given an array nums, let's say 2, 3, 2. And the value at each index of our array tells us the amount of money stashed in a given house, in a neighborhood, and we have been given a few conditions to rob all of them, and we have to tell the maximum that we can come out after robbing the entire neighborhood. So the conditions given are, we cannot rob the adjacent houses, so adjacent houses cannot be robbed, and the neighborhood is just like a circle. That means if there are three houses, they are like 1, 2, and 3. So what this does is, now the first house is the last house. So even if while solving our problem in House Robber, what we did was we simply calculated this plus this and said that the max that we can come out from the neighborhood is equals to 4. But now as this is a neighbor of this, or the first house is the last house, like say the first house, second house, third house. So house 3 and 1, they are both actually neighbors, so they are adjacent, so we cannot rob these houses together. So now our solution becomes this. So I'll just give a simple example, or just a simple trick that would help us solve this problem using the same logic, using the same approach that we used in solving House Robber. So now let's say we have a neighborhood, and let's say we have 1, 2, 3, 4, and 5 houses in the neighborhood. And now we start robbing from this house. Let's say this is the first house. And after solving the last problem, House Robber problem, we know that there are only two scenarios, that we either rob house 1, this, let's call it R1, and then we rob this house or the current house, and either we keep on our maximum amount just by considering that no, robbing house 2 is more profitable than robbing both of the houses. This was our condition for House Robber, and we can simply apply the same condition if we divided our problem into two arrays, which would be, the first scenario would be, we'll start robbing from the second house and keep on robbing till here. This will be one of our arrays. And the second scenario would be, we'll start robbing from the first house and we'll keep on robbing till here. So by doing this, we avoid the condition that the first house will again be the last house, so we cannot rob the first house and the last house together. So simply what we have to do is, first we'll define a helper function. Our helper function will be the same that helped us solve the problem House Robber. And this will only take an array, let's say, and what a helper function does is it calculates, let's say, R1, comma R2. R1 and R2 are robbing house 1 and robbing house 2. similar as we did in the problem house robber. And now we'll go on traverse our array for, let's say, n in our array. We'll say, and keep note of a temporary variable that will be maximum of either r1 plus n or r2. Then we'll set r1 as r2 and r2 as the temporary variable, and just return r2. And now we come to the main part of just switching our solution. And now what we have to do is we have to return either, we have to return the maximum of either self.helper function with nums houses of index 1 and above. Now we are not considering the house at index 0, so we are avoiding the problem that the first house is the last house, which would make both of them adjacent. Or what we can do is we can calculate self.helper, and now we'll not go or consider the last house. Just let me put this down here. And this third case, or the final case, is what if we have just a single house. So for that, we'll be considering nums of 0. And let's try and run our solution. As we can see, this is a pretty efficient solution. I hope you guys understood. Thank you and have a nice day.